They stand against the sky, silent sentinels on the edge of the desert. They have watched civilizations rise and fall. They have seen more than 4,000 years of sun and sand. And for all that time, they have held their secrets close. When we stand before them, we feel a sense of awe. A profound wonder fills us. We look at these mountains of stone, built by human hands. We ask a simple, yet powerful question. How? How did they build this? This question is not new. It has been asked for millennia. It is a mystery that has captivated thinkers, dreamers, scholars, scientists. It is a puzzle written in millions of tons of stone. The Great Pyramid of Giza alone is made of more than 2 million stone blocks. Some of these blocks weigh as much as a small car. Others, deep within the structure, weigh as much as a locomotive. They were lifted and placed with astonishing precision, hundreds of feet in the air. This was accomplished in an age without steel cables, without engines, without powerful machines. This achievement seems to defy the limits of its time. It pushes us to reconsider what is possible with simple tools and immense human will. This sense of disbelief can lead to fantastic theories. People have imagined lost technologies or help from otherworldly visitors. Every great structure begins with a single stone. For the pyramids, it began with millions. The first step was to find and extract the stone itself. The builders were expert geologists. They knew the land intimately. Core blocks came from quarries near the Giza Plateau. This proximity was a critical logistical advantage. For the smooth, white outer shell, they turned to Tura limestone across the Nile. Granite for chambers and sarcophagi came from Aswan, over 500 miles to the south. Cutting massive blocks was an art form. Without iron or steel, their primary tools were copper and dolerite. They chiseled, sawed with sand, and cut channels into bedrock, carving grooves around each block. Slow, grueling work. The rhythmic sound of stone hammers echoed through the quarries. Then, a clever trick. Dry wooden wedges, drenched with water. As the wood swelled, cracks followed the cut lines, freeing the block with control. Once a block was freed from the quarry, a new challenge began: transportation. Moving tons across sand and water is a monumental task. The ancient Egyptians were masters of logistics. Their greatest highway was the Nile. The annual inundation brought water, a gift for farming and for building. High water drew the river to quarries and site, enabling canals and harbors almost to the pyramid's base. Granite from Aswan and fine limestone from Tura rode stout cedar barges, feats of engineering in themselves. Reliefs show boats laden with stone. The river bore the heaviest load with small crews guiding the cargo. The rhythm of the river dictated the rhythm of construction. From harbor to site, friction was the foe. The solution was the sled. Prepared paths, wood or plaster, eased the pull. A tomb painting shows water poured before the sled. Physicists found the right moisture firms, sand, dramatically cutting friction, perhaps having the workforce needed. Getting stones to the base was one thing. Lifting them hundreds of feet was another. With no explicit plans left behind, we deduce methods from the evidence. Most scholars center on ramps, the ancient inclined plane for heavy lifting. A long straight ramp is possible, but as the pyramid rose, the ramp would stretch far, over a mile, using material nearly rivaling the pyramid itself. A spiral ramp corkscrewing outside solves length, supported by the structure, but introduces tight turns and blocks survey sightlines. A hybrid, external ramps for lower tiers, then an internal spiral within the body, a hidden internal causeway. Modern scans reveal anomalies and voids that could hint at such a system, saving material and leaving faces open for precision checks. Whichever method or combination as they used, it was a solution born of necessity and brilliance. Debate continues, guided by evidence, tested by engineering. A project of this scale requires more than stone and engineering. It requires people. For a long time, we imagined slaves under the whip. Modern archaeology shows a different picture. The builders were skilled, well-fed, respected Egyptian laborers. They were citizens, working for the king, the country, the gods. This was a national project drawing on society's strength. Housing, bakeries, supply depots, skeletons reveal medical care, set bones, even amputations. A permanent skilled crew was joined by farmers during the floods, tens of thousands traveling to Giza. In return, food, shelter, tax exemption, a form of national service. Organized into crews, the Friends of Khufu, the Drunkards of Menkaura, with pride and friendly competition. A temporary city mobilized, fed, housed, and managed for decades. Not monuments to oppression, but to social organization and cooperation. Beyond size and weight, what astonishes is the incredible precision. They were masters of measurement. Accuracy hard to match even today. The Great Pyramid's base is nearly a perfect square. Its sides align with north, south, east, and west. The north-south axis off by just 3/60ths of a degree. Long before the magnetic compass, they likely used the stars. The pole star method. Track a star circling the celestial pole. Mark rise and set, bisect for true north. Or the gnomon. Watch a pole's shadow. Find the shortest at noon, a north-south line written in light. They mapped the cosmos onto the earth, seeking harmony with the universe. Casing stones were cut and fitted so precisely that no knife blade fits between them. To level large surfaces, shallow trenches filled with water created a perfect plane. Then they chipped down to it. For verticals, a plumb bob, a weight on a string, kept walls true. Descending and ascending passages deviate only centimeters along their lengths, laid out with sighting devices, strings, and careful marks. The mystery of the pyramids is not static. Our understanding evolves with modern science. Archaeologists, engineers, geologists, and physicists test old theories and propose new ones. Computer models simulate forces and ramp stability, estimate manpower, time, and resources. Non-invasive tools, cosmic ray muon radiography, infrared thermography, ground-penetrating radar, let us peer inside without drilling. In 2017, a large hidden void was found. Its purpose remains a mystery. Hidden chamber, weight relief, or a clue to internal ramps. Experimental archaeology turns theory into practice, revealing physical demands, time, and skills required. They teach ingenuity with limited resources and deep knowledge grown outside modern science. From engineering to project management to social cooperation, the pyramids still instruct. If they achieved all of this with such limited tools, then what else did they know?